to exchange information and act upon that information. And therefore, my problem area has been to research and assess the interoperability within ecosystems to find out how they solve the problems and where the problems lay. And during my assessment, I also identified the stakeholders of the ecosystem to be able to also assess them from different perspectives and contributing to stakeholders information to the stakeholders. So I had 3 research questions during my thesis. With the first one is how does acknowledged IoT ecosystem provide and assure interoperability? This is where I'm going to research them and see how exactly they provide it, and if they don't, in what grade they do that, and then I can further see the strengths and weaknesses in the ecosystem I have chosen and then compare them. I also look into in what way connectivity affects interoperability, as connectivity is also recognized as one of the biggest issues in the IoT industry. And at last, as I mentioned, I have identified the stakeholders. This is because I want to see what consequences the technological and architectural characteristics have consequences for these stakeholders, and in terms of their own interest and interoperability. So for this thesis, I have had a very strict methodology. After I identified my problem and my research questions, I went on to choose what kind of ecosystem I wanted to assess. And I chose 3 quite different ecosystems to provide interesting results, and then to create a better picture of the whole IoT industry. And I first chose IoTivity, which is an open source project sponsored by Open Connectivity Foundation, implementing their own core specification. And I also have assessed Google Weave, which is Google's own IoT communication platform. And at last, I chose a more closed source ecosystem known as HomeKit, provided by Apple. And to obtain the information needed to do this assessment and research, I chose a research assignment combined by a study and experiments. And as I said, I have assessed this information using a criteria-based assessment, which is also used to assess software through a quantitative model where they choose specific criteria to, in a detailed manner, discover areas of the software that needs improvement. And at last, I analyzed the data I got from my model and assessment, and I went over to made it possible for me to then go over them and compare them and see the strengths and weaknesses and the ecosystem interoperability as a whole. So in my criteria-based assessment, I only had 1 criteria, which is interoperability, and I broke down the ecosystem into 5 small, what I call sub-criteria, which is the 5, what I identified as 5 layers of the ecosystem: the device layer, the network layer, the middleware layer, the application service layer, and the data semantics layer. And for each of these sub-areas, these layers, I also identified characteristics to further, in a detailed manner, be able to assess the layers. And here we can see an example of a summary in our results of the assessment of the network layer for each of the ecosystems. And on the left side, you can see the characteristics that was assessed. And first, my study was a qualitative study of official ecosystem documentation and API documentation. This means that I researched their architecture, specifications, standards, protocols, wireless technologies, and other technologies that was part of the ecosystem. And I also researched on the existing technologies that was a part of the ecosystem that was maybe not explained much in the documentation. I also conducted 2 experiments, one on IoTivity and one on Google Weave, where I simulated the ecosystem by simulating devices and using a client application to try to discover the simulated devices. And here the main goal was to get a more practical overview of the ecosystems and provide information that maybe the official documentation and other studies didn't give me. And this provided me, this experience gave me a much better understanding of how the data models work inside these ecosystems. And it also allowed me to see how third-party application was integrated, or if it was possible to integrate it into the system. And as well, it gave me more hands-on experience, and it also allowed me to test the development tools provided by the respective ecosystems, which is quite useful information both for device manufacturers and application developers. After I submitted my thesis, I also conducted an experiment on Apple's HomeKit. In my limitations section of the thesis, I also said I don't think that this experiment would affect my results. And after conducting this experiment, I have confirmed that because the HomeKit data model is kind of closed source. So even though they provide, I did this experiment, it still did not give me any specific results because of the development. It's kind of superficial. You don't really see what the technology behind it. So to my results. The most interesting and the results I found was all about the schema definitions. So the schema definitions are the data models that define the device's properties and functionality. This is more or less a common language for the devices to be able to exist together within the same ecosystem. And this is what allows one device to have like a temperature sensor to means that two devices, both temperature sensors, can exist in the same ecosystem, even though they are for different manufacturers. And even though these are quite similar, different ecosystems, they all have very similar data models, which is quite interesting. And also, I looked into connectivity, as I mentioned, and here I found that actually this kind of spread a little bit of spread support of connectivity protocols. For example, Google Weave only support Wi-Fi as its only connectivity protocol, and Apple HomeKit support Bluetooth Low Energy in addition to the Wi-Fi. And then we have activities which support both these protocols and also support the Zigbee, Z-Wave, and Optus, providing a much wider support for protocols. And then I looked into very interesting, which was bridging, which is allowing devices that are not really made or originally compatible for the ecosystem, and being able to bridge these into the ecosystem. And my results or the research found that both Apple and IoTivity allow for bridging of devices into their ecosystem, or at least it's possible. However, Google Weave, I have not found any evidence of bridging into the Google Weave ecosystem. And also, I just want to go quickly over operating system support, because this is kind of there's two different cases here, because IoTivity doesn't really show any restrictions of client-side application protocol operating systems restrictions. However, the IoTivity needs more of a physical middleware, like a gateway implementing the framework, and this gateway has to have there are some restrictions on OS running on these gateways. However, they support quite a lot of OSs. However, there are some restrictions, and when it comes to both Google Weave and Apple HomeKit, they don't really use this kind of physical gateway, because they either talk directly to the devices or they use the cloud as a middleware. Because of this, the operating system restrictions are more on the client side by both. For example, Apple HomeKit only supports client-side applications running on the iOS, while Google Weave supports both iOS, Android, and web applications, which opens a whole new door there. Well, for discussion, I found that because data models are such an important part of the ecosystem and the interoperability, I really want to see how are these data models standardized, and really the amount of standardized data models within the ecosystem is really what allows assess the amount of device types that can be interoperable within the system. And I found that IoTivity actually provides crowdsourcing for these data models, and this means that even though IoTivity has to approve them before they are really implemented into the ecosystem, it's still possible to for users to contribute to the data model. And as a result of this, IoTivity has implemented a large amount of data models. And Apple HomeKit also allow, they provide their own data models, but they also allow device manufacturers to submit the data models with their devices if the data model doesn't already exist. And at last, I found Google Weave doesn't really allow for any contribution to the data model. And I think this is why also Google Weave shows the most limited amount of accessible data models. And further look into the stakeholders, and stakeholders are really given a lot of responsibility by to provide really interoperability within this ecosystem, because the stakeholders really have to play by the rules of the ecosystem to be able to be a part of it. They have to like adapt to and almost obey to the data model. They have to obey to the data models. They have to adapt to connectivity protocols and architecture and so on. And on top of that, device manufacturers really have to provide their own way of provisioning and onboarding these devices into the ecosystem. And for the application developers, they also have to consider a couple of things, because they, first of all, when they choose the ecosystem they want to support or create an application for, they must kind of consider the operating system support, because going into iOS or the Apple HomeKit, they only need to develop this one application for iOS. However, that would mean their application would have a smaller user base than, for example, if they created an application for Google Weave, which supports with Android and iOS and web applications. But then again, you would have you could see that, for example, Google Weave has less data models. So how would maybe that Google Weave will not be that popular because there's less interoperable devices, and maybe it becomes less popular, and after all, the user base wasn't bigger than HomeKit anyway. And for limitations, one of the main limitations in my thesis are the characteristics of my assessment model. The reason for this is these characteristics are identified by me during my study and my research and my experiments as what I've seen as the most important part of providing interoperability in each of the layers. Yeah. And I would also like to, one thing that during my research, I found when I got over to the bridging part, this was really interesting because this is one of the, I feel like one of the solutions to really open doors in interoperability, because I really don't see there being one big ecosystem removing the interoperability problem once for all. I really see it more of a solution to bridging, and actually Apple HomeKit has a open source tool created by users, which is called HomeBridge, which is a Node.js server emulating the Apple HomeKit API to display the device that's not necessarily compatible with Apple HomeKit as Apple HomeKit devices on the network. And I saw this as a good chance for device manufacturers to maybe create their own what I call a bridge hub, where they could implement where they could then provide a bridge hub to their devices, and then as they also will need a provisioning application, they could by provisioning, let's say they want provisioning to an onboard Apple HomeKit, they would then report to the device, the bridging hub, and this would then emulate the correct API and present it as a HomeKit compatible device. And this, I see this bridge as being possible to also emulate other ecosystems, making it possible for this hub to be able to onboard and emulate and make these devices that are not really compatible with an ecosystem compatible. Yeah. So, and yeah, to answer my recent questions, all of these ecosystem provides what's called end-to-end interoperability. They provide interoperability between devices and also third-party applications. However, they do it, as mentioned, with restriction because of the data models and the operating system support. And also we talked about in discussion, interoperability is very much restricted by connectivity, and all stakeholders are also very restricted. And as I said, they have to obey, the device manufacturer has to obey the data models and adapt to the specific technologies of the ecosystems. And this kind of is what really makes the interoperability a problem, because the ecosystem kind of forces the device manufacturer to create devices that are really locked to a specific ecosystem. And then you also have the device, the application developers, which really has to choose what kind of user base they want to support, and if they want to support the ecosystem based on maybe the possibility of interoperable devices, and maybe then try to evaluate which one is more possible or more popular. And they also have to choose if they want to support if they choose to support an ecosystem that has support for multiple operating systems, such as Google Weave. They would then have to maintain and develop two applications with two different operating systems, which is a bit more costly and time-consuming. Yeah.
Okay, thank you. Yeah. Thanks for the presentation. This is a timely and interesting topic. This is going to be the next revolution, isn't it? I think so, at least.
Yeah.
You're doing an applied computer science master.
Yeah.
That means that what we do for an audience. What is your target audience?
Yeah.
For this?
So the main motivation behind this is kind of, I want to enlighten the industry of where this problem really lies, and if it's possible to look at, okay, I mean, when I started looking into interoperability, it kind of feels kind of vague. Exactly where is the interoperability problem? And this is why I went through all of the, I made my assessment model and split it into layers to see where's the strengths, where are the weaknesses, where really lie, where's the really is the interoperability problem. And I also did this with the stakeholders in mind, because I wanted to assess them from these different stakeholder perspectives to really make it possible for the industry to really see, even though which or not depending on this what kind of stakeholders are, really enlighten the industry on the interoperability problem.
Sure. Okay. Yeah. And you stated in your thesis, so I'm asking to have a bit clarification from it, and it's about two definitions. One is ecosystems, one is interoperability. Yeah. So you refer to some industry definitions of it and some academic definitions. What is your interpretation of ecosystem and interoperability in your project?
Okay, so my definition of or how I see an ecosystem is an environment or a set of structured rules and a kind of foundation. I feel like it's a playground for devices and applications to be able to integrate it. And to do that, I mean, an ecosystem is built upon architecture, a specification, and a set of support or a set of technology to support. And this comes with the API, where we kind of map the API on top of the different the software stack to provide an ecosystem together with the data models to allow to create an environment for these devices to live in.
Okay. So then the interoperability then, is that then between devices within one ecosystem, or could I think that interoperability could be manufacturer independent or perhaps even architecture independent?
So yeah, I feel like this is what I also still find confusing about interoperability and really got me into it in the first place. I have assessed interoperability within ecosystems, and because of the architecture and data of the ecosystem, of course, they are made to provide interoperability among the devices that are implemented with these specifics and characteristics. Yeah, and you asked some more about interoperability, which was
Could interoperability is for you as I read you within one manufacturer. It could be or within one what you define as the ecosystem. So Google Weave and the Apple HomeKit or the IoTivity. Those are defined as from you as different ecosystems.
Yeah.
Could I think of interoperability between the whole, let's keep the HomeKit out of it, but let's say IoTivity and the Google Weave as well.
Yeah, interoperability between those.
Mm-hmm.
Yeah, and that's where I've been looking into bridging, because I don't. My perception of this after my study is that you can't. And what I saw also in the industry is the problem with kind of vendor locking, and where as a device manufacturer, I choose to support IoTivity, and then I kind of have to obey those data models, and then all of a sudden I can't. And this device won't be able to work with Google Weave. And that's where I'm really interested in looking forward to if it's possible to bridge. And that's where I see, like, okay, you have interoperability within an ecosystem, but is it possible to create interoperability between ecosystems? And that's where I want to see this bridge, which is kind of where I think is a solution for this industry, as I don't see it really being I don't see it possible for it to just exist one ecosystem and create this internet of everything dream scenario that everyone is dreaming about.
So what concretely is then the bridge for you?
Okay, so a bridge, as I've seen, is that I want, yes, as mentioned, the Apple, the whole bridge is, I want to, or as I see a bridge is like the middleware between a device not originally supporting an ecosystem, implementing other characteristics, or maybe not even supporting the wireless technology, being able to be bridged into an ecosystem which is not originally meant for through this bridge.
Sure. Okay. You mentioned and you referred to some of the initial work, for instance, by Google and more. And based on their work, there's also been done quite a fair amount of work on a bit larger scale overall IoT architectures, which tries to say, well, for instance, we have a device layer where these different manufacturers, they live in a device layer. So we can have Google Weave, HomeKit, IoTivity, all at the same bottom level, feeding data into a larger architecture, larger system. Do you know any examples of such architectures, such work looking into those kind of perspectives?
I can't really say I am familiar with that, because kind of extent of interoperability outside the ecosystem, the farthest I actually gone is looking into the bridging. So I'm not familiar with one of those architectures. I'm just going to think. Let's see.
Right, it's fine, but if you would like to pursue this further, it might be in a direction we would like to look into. Going a bit into your device testing or your experiments on interoperability. For several of these, for your tests, you do implement server side and do some emulation simulation of the sensors. Do you see any limitations by doing that?
I mean, I would say that I see some limitations in my Google Weave experiment, because I kind of take both of I use development tools that are provided by Google, which kind of makes my experiment, it will work because it's set up to work. But the main goal of the experiment wasn't really to see if of that experiment was really to see if I was able to discover that Google Weave simulated devices with the Google Weave developer applications, more to see how can I investigate the data models and how the data models work.
Yeah. Do you think your results would have been different, or your results in terms of how you, because you have now some reports based on the specification on the APIs, these different vendors, how they report their supposed to change the data, their supposed interoperability is. Do you think your results could be influenced if you had, for instance, when you will try to implement Weave plus an Android Things device?
Yeah, and I think I'm answering your question because when I studied the documentations, I also mentioned in my paper that my results are also based on how the quality of the documentation, and what I am actually thinking about afterwards is that this documentation is also trying to sell the ecosystem to the device manufacturers and application developers. So therefore, I'm kind of agreeing that a more standalone ecosystem implementation might give me results, other results that could eventually maybe affect my results.
Because the results you report on are then based on the vendor's own words, how they express their the specification is supposed to be.
Yeah, it's based on the documentation and the specification provided by the ecosystem vendors,
yeah,
and my tests.
Yes, there might be some surprises if you try to implement it live.
Okay.
It's, as you say, they sell their ecosystem. Interesting. You talk about in the start Internet of Things versus Web of Things.
Yeah.
Would you care to define two concepts for me?
So I mean, I think Web of Things is kind of getting more and more worked into the Internet of Things. I think they were more separate at the start, and this is kind of using the web as a platform for the Internet of Things to be able to provide a more open solution. Which I think that these are also kind of built on the Web of Things platform using the RESTful architecture and also the utility using more of REST API. I mean, yeah, I think they kind of they blend more into each other now than they did before.
Final question for everybody. Do you know the concept of fog computing?
Yeah, I think it's that when you compute on the edge of an ecosystem. I mean, I think, or it's the edge computing. Or
I'm asking you.
yeah. I have read it. I am familiar with it. I think that is when you compute the information before it kind of leaves the area.
Yeah, absolutely. What would be the benefit of that?
I think that the benefits of that will be, well, I think you would need, for example, the more cloud solution. Maybe if you have a more ecosystem that was more, or a middleware that was more, for example, activity, which have a more physical middleware where you can complete everything before you pass it directly to a user, and where you don't have to send it to a cloud where it maybe has to be analyzed, and you can compute everything on the spot. And I think that I haven't looked much into security, but I believe that would also come to prevent some of the security issues when you don't have to maybe compute it in the cloud and store it there, and before you pass it further.
Right. So I have similar questions around the interoperability definition. Yeah. So when I started reading your title and the introduction, I thought, okay, I will get the answer to how to plug my smart lock to my smart heating system with my smart light, yeah, which are all coming from 3 different manufacturers using different protocols. Yeah. But that wasn't the case. And while reading the work, it kind of I was wondering what is exactly the definition of interoperability that you've been using, and that question has been asked already, so you kind of explain a little bit. But to me, the work within a single ecosystem, as you define it, is just operability, like how it just works. It's not about how it interoperates with other things. So that was one question which was already discussed. The other question I had was how is typically interoperability addressed in computer science in our field, like how we solve interoperability problems.
So, as I understood, it's all about the data and making both devices and applications understand each other based on the data models. So this is more, but I didn't much touch it, the semantics, where actually two devices can understand each other based on a specific data model, because
so how we do that? How we enforce that they can understand each other?
Well, yeah, I haven't really looked into much of the semantics, but I mean, yeah. Yeah, I haven't really looked into it, but that's very interesting.
Right. So so that was one. The other thing was, if you were to address the problem that I just described at the beginning, like I have a smart lock from one manufacturer, I have a heating system from another, and a light from another, and I would want them to talk to each other. What would be required? How would that scenario change the methodology and the architecture that you presented in the report?
So these are from different manufacturers. You want them to be able to control them all from the same application.
Ideally.
So then for my research has shown that they would then have to, even though they are from different manufacturers, they would be the manufacturer would need to implement the data of this specific ecosystem, and then you would be able to use the application supporting this ecosystem to interact with all of your devices. But however, if you were to have maybe two devices that support the ecosystem and not the third one, then that's where you have a problem, because then either you have to also implement in your smart environment and a second ecosystem supporting this as this third device, and then you have two ecosystems, one ecosystem with two devices and one ecosystem with one. And as what I haven't looked into, what it might be possible for this is an application that can interact with two different ecosystems. That is actually something that I would be interested in looking into further. We had to implement different ecosystems in home, but at least you would just remove the need for multiple applications. Mm-hmm. Or you would have to come up with some of the bridge solution I was talking about, where you bridge this third device into the single ecosystem environment.
Mm-hmm. All right. So for your work, you picked those three kind of ecosystems as you define it. So what was the rationale for that? Why didn't you consider like devices which are using Z-Wave, for example, or so? What was the criteria to kind of base it on that level that you did?
Yeah, because when I've been researching interoperability, I kind of find that the main problem is that these I read about the framework and the ecosystem like being the main problem, and that these are the problems that are really looking the devices into this like vendor login into the specific vendor of the ecosystem, and that's why I really wanted to choose these three very different on the outside looking in, like the different ecosystem to see if there is similarities or differences, and I did not, for example, choose to look at ecosystems on the supporting devices like Zigbee and so. I mean, when I started my thesis, this was what I saw was the main problem, and after I defined that, I really wanted to look into two ecosystems, and then that's why I chose these three very different to see if there was strengths and weaknesses in comparing them and how they solve their interoperability problems.
Okay, thank you.
We have time for some additional questions. Do you have any questions? Yeah.
break.
Thank you.